Here we go with sample spaces of compound events. Number one, Beatrice is making her lunch and wants to include a piece of fruit and a vegetable. For fruits, she can choose an apple, a banana, or an orange. So she has three fruits. For vegetables, she can choose broccoli or carrots. So she only has two vegetables. Which of the following diagrams shows the sample space if Beatrice chooses one piece of fruit and one vegetable? So the sample space is everything that could possibly happen. So what is the sample space that A is showing? You've got an apple, a banana, and an orange, and each of those has two branches. Each of these are like a little mini tree. The apple has the branch broccoli and carrots. So the apple choice has a broccoli option and a carrot option. So if I look over at this piece right here, this doesn't just mean broccoli, this means apple and broccoli. So that's one choice. The next choice says carrots, but it's actually an apple and carrots because you're including the branch that the carrots came from, which is apples. The next choice over here is banana and broccoli, then banana and carrots. So far, so good. Over here, we have orange and then banana. Do we want to do orange and banana? No, that's two fruits. Orange is a fruit and so is a banana. We want one fruit and one vegetable. So A is wrong because the orange tree over here, instead of having broccoli and carrots like the other two, has banana and carrots. So A is not true. Next one, apple, broccoli, carrots. It looks like the top here has broccoli and carrots with an apple. Doesn't make sense. All of these should be the same. They should all branch from fruits or both branch from vegetables. Of course, the carrot tree, if you're going to start with the vegetables, there are three fruits to choose from. So if you start with a vegetable, you should see three branches instead of just two. If we look just at the carrot tree over here, it has carrot orange, it has carrots banana, but there's no option for carrots and apple. So if you're going to start with one of the two vegetables, then each of those branches or each of those trees should have three branches. So B is not right. Let's look at C. It starts with apple, broccoli, carrots. That's good. Banana, broccoli, orange. No, again, banana and orange are both fruits. That doesn't work. And then also over here, we have a carrot tree all of a sudden. We're starting with fruit trees. We have fruit, fruit, and then vegetable. That doesn't make sense. Lastly, D. We have apple, banana, and orange at the top. We have three trees because there are three fruits. And each of those trees has two branches because there are two vegetables we can pair with each of those three fruits. So apple and broccoli is one combo, apple and carrots is another. Banana and broccoli is a combo, banana and carrots is another. Orange and broccoli is another combination, orange and carrots is the last combination. So what this shows right here is six different outcomes. If you're wondering where the six outcomes are, let me point them out. The end of each one of these branches is an outcome. This outcome right here, and let me make that a little bit bigger so you can see it. This outcome right there is apple and broccoli. I'm putting it under the broccoli, but the broccoli is attached to the apple. So this outcome is apple, broccoli. That's one combo. Then this is another combination, apple, carrots. So there's two. Banana, broccoli. That's three. Banana, carrots. That's four. Orange and broccoli. That's five. Orange and carrots. That's six. So D lines up all six possibilities for what could happen if you try to pair three fruits with one of two carrots. Number two, the table shows the t-shirt options for a clothing store in size, fit, and color. So you've got size small, you got the type of fit, and you have the color. Now you notice that there are four different sizes: small, medium, large, and extra large. There are four fit types. There's full fit, regular fit, classic fit, or athletic fit. But there's only two colors to choose from. There's only green and white. You only have those two colors. So which list shows the correct sample space with all possible outcomes for a classic fit t-shirt highlighted? So which of these options, we have four different tables here, which of them has highlighted all the options for a classic fit t-shirt? So if we have a classic fit t-shirt, it could be one of four sizes and it could be one of two colors. So we should find 8 total options for a classic fit t-shirt. We should have a classic fit t-shirt that's small and green, classic fit that's small and white, a classic fit that's medium and green, a classic fit that's medium and white, classic fit that's large and green, a classic fit that's large and white, a classic fit that's extra large and green, and a classic fit that is extra large and white. So which one of these tables has those indicators? Now, if you look at these, it starts off in the same order that our table is. The first letter represents the size, the second letter represents the type of fit, and the third letter represents the color. So we want to make sure that the type of fit is classic for each one of these, because right now we only care about the classic fit. So let's go ahead and look at W. Do we have classic fit for all of these highlighted options? Yes, they each have C in the middle. Next, do we have the two small options for our classic fit? Yes, we have small, small. Then we have two mediums, medium, medium. They have two larges, large, large. And we have two extra larges, extra large, extra large. Finally, do each one of those have the one green option and the one white option? Yes, here's small classic green, small classic white. Then we have next medium classic green, medium classic white, large classic green, large classic white, and extra large classic green, extra large classic white. So W, the first one we checked, is the answer. Let's see if we can't find out what's wrong with the other options. Over here for option X, we have small classic green, small classic white, so that starts off okay. Medium classic green, medium classic white, still good. Large classic green, large classic white, and then extra large classic green and extra large classic white. So what is the problem with this one? Well, it shows the right sample space for the classic fit t-shirt, but it also wants the correct sample space altogether. So we're missing other options here. Take a look at W again. You've got 8 options for fit, for full fit. You've got 8 options for regular fit, 8 options for classic fit, and 8 options for athletic fit. If you go ahead and look at X, we don't have all of those options. All the options for X, well, we have 8 regular, and I'll go ahead and draw so you can see here. Let me highlight all 8 that are going to be each of the different colors. Full fit, that is these 8. Those are all the full fit. Then in blue, I'll put the regular fit. Blue, that's all the regular fit options. Then in yellow, it's already highlighted, the classic fit options. So there's the yellow ones. So it's already highlighted in yellow. I'm just putting more yellow. And then finally, the athletic fit, I'll put in green. Here are the athletic fit options. Let's compare that to table X. Where are the full fit options? Well, there's only 4 of them. See how it says small, medium, large, and extra large with the F, and they're all white? What happened to the green options? Those are all gone. So you can see here there's 8 options on table W for the full fit, but only 4 options on this table. So it's missing those. It does have all the regular fit options. It has these 8 in blue. And it does have the 8 yellow options that we care about. It's also missing half of the athletic options at the bottom. Notice that it only shows the green options for the athletic fit shirts. It has small athletic green, medium athletic green, large athletic green, and extra large athletic green, but there's no W's, there's no white t-shirts. So it's missing 4 from the full fit and 4 from the athletic fit. Okay, well, what about table Y? It's got all the options, right? It's got the same number of rows as table W, but what's highlighted? Are the classic fit t-shirts the ones highlighted like we care about? We want the classic fit t-shirts according to the prompt. What's highlighted in table Y? Only the regular fit t-shirts. And table Z is obviously missing some combinations just like table X was. What is table Z missing? Well, it's got all the regular or all the full fit. So if I go in pink and I find the full fit options, all 8 of those are there. But look what's highlighted. The regular fit that I put in blue everywhere else is the one that's highlighted. That's not right. It's missing those. It has all the athletic fit, but the highlighted ones are not the right ones. The highlighted ones we want to be the classic fit, but it only has highlighted the regular fit, and the classic fit ones that we care about are completely missing. So our answer is W. Number 3, Josie randomly selects a sweater and then a pair of shoes. Josie has a red sweater, 2 blue sweaters, and a white sweater. So how many sweaters does she have? She has a red sweater. That's one red sweater. Two blue sweaters. So that's two more, three sweaters total. And a white sweater. That's four sweaters total. She has a pair of black shoes, a pair of brown shoes, and a pair of gray shoes. So she has three pairs of shoes, black, brown, and gray. Select which tree diagram, diagram 1 or diagram 2, can be used to find the probability of the event of selecting a blue sweater and then selecting a black pair of shoes. So let's go ahead and look at the diagrams here. Diagram 1, you see red, you see blue twice. Why do you see blue twice? This first part of the tree, this first branch, represents the sweaters. And there are two blue options because she has two blue sweaters, whereas she only has one red sweater and one white sweater. So there's one red branch to represent her one red sweater. There's one white branch to represent her one white sweater. And then there's two blue branches to represent her two blue sweaters. After that, there's a branch off of each one of those sweaters for her one pair of black shoes, one pair of brown shoes, and one pair of gray shoes. So altogether, we see all of the correct options for diagram 1. Diagram 2 does not work because it treats blue the exact same as red and white. But since there are more blue sweaters than the other two colors, you cannot put the same emphasis on blue as red and white. Blue has more options. So diagram 1 is the answer here. Now, clearly on this, if you're paying attention, you also need to select what it says right here, the end of the paths that correspond to this event. So what does that say? We want to select a blue sweater and a black pair of shoes. So if we continue through this, we have the blue branch right here and another blue branch right here. And we need to highlight those two sections because those two options are the end of the branches that have a blue sweater and a black pair of shoes. So don't make a silly mistake. Blue sweater right there and a black pair of shoes. So these two ends represent a black pair of shoes with a blue sweater. Had we chosen, say, this black, that would have been a black pair of shoes, but with a red sweater. So that would not work. This also would have been a black pair of shoes, but with a white sweater. So don't make a silly mistake. Number 4, an ice cream shop offers 4 flavors of ice cream, 2 types of cones, and 2 choices for toppings as shown in the table below. If only one ice cream flavor, one type of cone, and one topping choice is selected, which of the following lists all the possible outcomes for a regular cone? So you got a regular cone, and it could have one of these 4 ice creams and one of these 2 toppings, and the 2 toppings being peanuts or none. So which of these has everything possible outcomes for a regular cone? So first off, we're only looking for regular cone outcomes here, not chocolate cone. So anything that has a C in the middle, where we're noting the type of cone, should be discarded. So W, you can see the middle of all of these is R for regular. That's good. X has the same thing, only R is in the middle for regular. That's good. Y, one of these is a C. That shows a chocolate cone option. We don't want that, so Y is out. Z also has plenty of options that have C for chocolate rather than R for regular. So Z also out. Let's go back and look at W or X. Which one of these is accurate? Well, we want to make sure that vanilla, strawberry, banana, and mint are chosen for each one of these options. And sure enough, vanilla, strawberry, banana, and mint. And on the other column, vanilla, strawberry. Uh-oh, there's another vanilla. That is not what we want. We want vanilla, strawberry, banana, and mint. So we clearly have a problem here. Now you might be thinking, oh, well, there's a B over here. Well, that third letter, that is supposed to be the list for the toppings. The toppings are either peanuts or none. This over here has an M, so that's wrong. And B, those are not toppings. Those are the wrong option. Take a look at X. Vanilla, strawberry, banana, and mint. Vanilla, strawberry, banana, and mint. All of these represent the peanut cones, or the peanut toppings. And over here represents no toppings whatsoever. X is the right answer. Number 5, Emilio has 4 red buttons, 1 green button, and 2 black buttons in a jar. Which list shows all the possible unique outcomes if Emilio chooses 3 buttons at one time from his jar? No, one outcome is shown per row in the tables. So each row is one outcome. So if we look at W, the row says red, red, red. That would represent choosing a red 3 times. So again, we have all these buttons, and we're going to choose 3 buttons at once. So is one possible option red, red, red. Could we get 3 red buttons? And the answer is yes, because there are 4 buttons in the jar. So it is possible that if we reach in, we get 3 red buttons. What else could happen? We could get a red button, and a green button, because there is one green button. What else could happen? We have a red button, a green button, and another green button. Is that possible? That if we reach in at once, we get 3 buttons at one time, can we pull out 2 green buttons? And the answer is no, because there's only one green button in the jar. So W does not make sense. We cannot get 1 red button and then 2 green ones. There's only 1 green button in the jar. It's impossible to pull out 2 green buttons at once. Next, choice X. Let's take a look at that. It starts off with red, red, green, which is possible. We could pull out 2 red buttons and 1 green one. Next is red, red, black. We could get 2 red buttons and 1 black one. But what happened to red, red, red? Didn't we say that was one of the options on our last one? Do you see red, red, red anywhere in table X? No, that's missing. So we have a problem with table X already. Black, black, red is an option because there are 2 black buttons, so we can pull out 2 at once and then 1 of the red buttons. Black, black, green is an option because we can pull out 2 black buttons and the 1 green one. And we could pull out 1 red, 1 green, and 1 black. So all of these are options, but there are options that are missing, specifically red, red, red. Let's go ahead and look at table Y. Well, there's clearly fewer options in table Y than there are for table X. So if table X didn't have enough options, table Y certainly isn't going to. That leaves us with table Z as the only result left and has to be the right answer. And sure enough, it's got the red, red, red we were looking for, red, red, green, red, red, black, and then black, black, red, black, black, green, and red, green, black from table X. Number 6, the blank is the collection of all possible individual outcomes for a chance process. The total probability of all the possible individual outcomes is blank. So the sample space is the collection of all the possible outcomes. Our other choices besides sample space are probability model, relative frequency, and probability. Those are not what we're looking for. Sample space is what this section is about, and the sample space is what you call the collection of all the possible individual outcomes. If something has to happen, then it should be in the sample space, which means every possible outcome should be in there. So all the probabilities of all the outcomes added together needs to be 100%. 100% is what the possible outcome maximum percentage is. It can't be more than 100%, and it can't be less if you're talking about everything in the sample space. And we look at these options, you may notice there are no percent symbols. You have to choose the number that's equal to 100%, which is the number 1. Don't choose 100. When we do probability, we do scales from 0 to 1. 0.5 is a half or 50%. 0 is 0%, and 1 is 100%. They put the 100 in there just to trick you. We only put 100 if there's a percent symbol following it. So 1 is the total possible outcomes if we add them all up. Number 7, a customer at an athletic store can choose from running, walking, or cross-training shoes. The customer can also choose from cushion or compression socks. So which of the diagrams shows all the possible combinations of one type of shoe and one type of sock? We should have 3 trees if we're going to start with the type of shoe, each with 2 branches if we're going to have the type of sock branch off of each of those trees. Because what we're looking for here is from 3 different shoes, they can choose 2 socks. Each of these below shows 3 trees, so each tree better start with running, walking, or cross-training. The first one does, but each of those only has 1 branch. Running only has cushion. What about running with a compression sock? And walking only has compression. What about walking with a cushion sock? And then this tree over here is all wrong. It's got cross-training and running. That's 2 different types of shoes. We don't have both of those at the same time, so A is completely wrong. B has running, walking, and compression. Oh, wait, running, walking, and compression. Compression is a type of sock, not a type of shoe. We want running, walking, and cross-training. So this is not what we're looking for. This last tree over here has compression cushion as one of the options. Those are 2 types of socks. We need 1 shoe and 1 sock, or 1 type of shoe and 1 type of sock. C has cushion, compression, and cross-training. So again, they're mixing up the socks and the shoes, and a couple of these don't make any sense. For example, you have cross-training and walking shoes at the same time. That's not one type of shoe and one type of sock. That's two types of shoes, so that's all wrong. And finally, D, running, walking, and cross training, the three types of shoes. Each of those with two branches, cushion and compression, the two types of socks. Number 8, Rolando tossed a coin 4 times. Which of the following is a list of all the possible outcomes with 2 or 3 heads? So we're looking for what happens if you toss a coin 4 times, but we only care about a list of the possible outcomes that have 2 or 3 heads. So let's take a look at table W. We've got 2 heads there, 2 heads there. We've got 2 heads in this option. The first flip and the third flip are both heads. Here we've got 3 heads, the last 3 flips. 2 heads here, 3 heads there, 2 heads there, 2 heads there, 2 heads there, and 3 heads there. So W has all options that have 2 or 3, but is it all the possible outcomes? You have to check for a couple things. 1, that none are missing, and 2, that you haven't repeated any. So take a look through the list and make sure that none have been repeated. Let's look over at table X and make sure that we have all 2 or 3 heads in that table as well. You have 2 heads there, 2 heads there, 2 heads there, 3 heads, 2 heads, 2 heads, 2 heads, 3 heads, 2 heads, and 3 heads there. So again, we have to make sure we're not missing any and that we haven't repeated any. Next one over here, 2 heads, 2 heads, 2 heads, 3 heads, 2 heads, 3 heads, 2 heads, 3 heads, and 2 heads, 4 heads. Well, that one's a lot easier to spot the wrong one because right away we have one that has 4 heads in it, and that's not what we want. We want options that have 2 or 3. That's it. So Y we can eliminate. And finally Z, 2 heads there, 2 there, 2 there, 3 there, 2 there, 3 there, 2 there, 3 there, and 2 there, and 3 there. So we've eliminated Y, and now we have to make sure that we're not missing any from the other 3 tables and that we haven't repeated any from the other 3 tables. So right away, let's go ahead and start with W, and let's see if we can eliminate repeats. That's the first thing that we can try and check. Since they all have the exact same number, odds are that we're not going to have extras or missing ones. We're just going to have repeats. So let's look for this. Start off with heads, heads. How many of these starts with 2 heads? This one does, and the one down here does, but it has a 3rd head, whereas this one doesn't. Right here. These 2, heads, heads, tails, tails, and heads, heads, tails, tails, are the exact same. So those are repeats. That does not show all the possible outcomes. It's got 2 that repeat itself. So W is out. We already got rid of Y because it had all of these ones right here. So now we only have 2 options left, table X and table Z. Let's go ahead and look for repeats in table X. Again, you could start with the ones that have 2 heads. 2 heads there, 2 heads there, but the 4th one is heads. 2 heads there, but the 3rd one is heads. So that starts off okay. What about where the last 2 are heads, like the next option here? How many have the last 2 as heads? This one, and any other ones? No other ones. So it looks like we might be missing one because we should have one that has 2 heads at the end, but also a head at the beginning of it. We should have heads, tails, heads, heads, and I cannot find that option in this selection. So let's go over to table Z and see if we can find everything. Heads, heads, tails, tails, just like this one. Tails, tails, heads, heads, just like this one. Again, we have the 2 heads at the end there, 2 heads at the end there, 2 heads at the end there, and there we go. We have heads, heads at the end, and then we have 3 heads at the end, and we have heads, tails, heads, heads. So it's missing it's got the one here, heads, tails, heads, heads. I'll mark it in green. This option in table Z has 3 heads. Does that option appear anywhere in table X? No, it does not. So clearly table X, there's a repeat somewhere else that we can find if we want to, but just knowing that we're missing one is good enough to know that table X is not the right option. And if you're looking for the one that is repeated, you can find it, and I'll put it in pink right here. Heads, tails is right there and right here. They repeat the heads, tails, heads, tails. So table Z is the one that shows all of our options. Table Z is the answer. Number 9, an urn contains 1 red ball, 2 green balls, and 4 blue balls. 3 balls are randomly chosen from the run. How many different color combinations are possible? So here we just have to list all the combinations if we choose 3 balls randomly at one time from the urn. So let's go ahead and count them all up. Let's make a list. Let's start off with, and I'll put dots here so that we can list it. If you were writing this down, maybe you'd want to write R for red, G for green, and blue for B, or B for blue. I'm going to go ahead and just put dots that are all the colors that we have here. So let's say we start with red, since there's one red ball. So I'll start with pulling out a red ball. If I pull out one red ball, what else could I pull out? Could I pull out another red one? No, there's only one red ball in the whole bucket, or whatever we've got here from this urn. So now we have to choose something else. How about a green one? We could pull out a green ball. And could our third choice be another green ball? Absolutely, because there are 2 green balls available. Our next one, we could pull out the one red one to start with again. We could choose a green one on our next choice again. But then I'm not going to choose green another time because we already chose that. So now let's try blue. Could we pull out one red one, one green one, and one blue one? And absolutely we could. Next, we could start with the red one. Then instead of having a green one, maybe we have one blue ball. And then after that, we could have another blue one. Now notice that I did not include red, blue, green because we have red, green, blue, and that's the exact same thing in this case. We don't care what order the balls are in because we're just pulling all 3 out at once and looking at them. So if I were to go over here and list red and then blue and then green, that would be a repeat of the second option right here. So I'm not going to do that. I'm not going to use that option. Next, what else could we do? Could we pull out a red ball again? Well, let's see. We already had 1 red and 2 green. We already had 1 green, or 1 red, 1 green, and 1 blue. And we had 1 red and 2 blue. Are there any other options? The answer is no. So now we can list all the options that have nothing to do with a red ball being pulled out. Could we pull out 2 green balls? Yes. So 1, 2. Could we pull out a third green ball? No, there's only 2 total in the urn. So we can't pull out a third one. We have to pull out either a red one, but that's already been counted up here, or a blue one. Lastly, what happens if we pull out a blue ball and then another blue ball and then another blue ball? That is another option. What happens if I pull out 1 blue ball, a second blue ball, and then a green ball? That's another option. You can pull out 2 blue balls and 1 green one, or you can pull out all 3 blue balls, or you can pull out 2 green balls and 1 blue one. This here is all the options that we have. There are no other options. It doesn't matter what order they're in. So as soon as we eliminated the 3 ways that you could pull a red ball out, what we have left are only combinations of green and blue. You can pull out all the blue ones, you can pull out 2 blue ones and 1 green, or you can pull out 1 blue one and 2 greens. But you can't pull out all green ones because there's only 2 green balls available. So we have 1, 2, 3, 4, 5, 6 options. So D is the answer. And number 10, during a basketball season, there are 5 teams in a division. Each team will play every other team in the division once. Which diagram shows all the possible games within the division? So let's take a look at this. W just says team 1 playing team 2, and that's it. Team 1 doesn't play anybody else. So already W is bad. We're looking for each team to play every other team in the division. So team 1 doesn't play any other team besides team 2 in diagram W, so diagram W is out. What about diagram X? I see team 1 playing team 2 and team 3, but is there any part of this diagram that has team 1 also playing team 4 and team 5? No, team 1 is not matched up with team 4 or team 5 anywhere in the diagram for X, so X is out. We need team 1 to play every other team one time. Let's jump down to Z. Here it shows team 1 playing all the other teams. That's what I said we were looking for, right? But wait a minute. Does it also show team 2 playing each of the other teams? No, this only counts team 2 playing team 1. What about team 2 playing team 3 and team 4 and team 5? And what about teams 3, 4, and 5 playing each other? So table Z or diagram Z is not good enough either. Take a look at diagram Y. We start off with team 1 playing team 2, 3, 4, and 5. Then we have team 2 playing team 3, team 4, and team 5. You might ask, well, what about team 1? We already counted team 1 playing team 2. I don't need to put a 1 branch in the 2 tree because that would be repeating the game between team 1 and team 2, and we only need team 1 and team 2 to play each other one time. So this diagram shows team 2 playing 3, 4, and 5. We already had team 2 playing team 1. So the first part of this diagram shows all the Team 1 games. The second part of this diagram shows all the Team 2 games, except for the one we already counted. The next one shows Team 3 playing Team 4 and Team 5, which is all we need because we already counted Team 3 playing Team 2 and Team 3 playing Team 1. And finally, the only game left would be Team 4 playing Team 5, and that's this last part. So Y is the answer on that one. All right, so work hard on that. Make sure you don't make any silly mistakes. Read through everything carefully, and don't forget to reach out if you need help. Good luck and work hard.